In this video, we will solve an interesting question on elasticity. The question is, the demand function Q1 is equal to 50 minus P intersects another linear demand function Q2 at P is equal to 10. The elasticity of demand for Q2 is 6 times larger than that of Q1 at that point where P is equal to 10. The demand function for Q2 is, options are being given, we need to find out the correct option. Okay, so we are being given the demand function, that is Q1 is equal to 50 minus P. Okay, we have another demand function that we are supposed to find out, that is we need to find out the demand function for Q2. Okay, and what will be the demand function look like? It will be like this, A minus B times P. Okay, so we need to construct this kind of demand function. We need to find out the value of A. Further, we are being told that P is equal to 10, where Q1 and Q2, the demand function is intersect with each other. Also, we are being told that the elasticity of demand for Q2 is 6 times larger than that of Q1. That is, let us denote the elasticity of demand of Q1 by E1. It is rather the elasticity of demand for Q2 by E2. It is equal to, it is 6 times larger, that means 6 times the elasticity of demand for Q1. That is being given us. So let me try to draw a simple graph here to explain, and let me see if I am within the limits also. Okay, so we have quantity Q on the horizontal axis, P on the vertical axis, that is price. Elasticity of demand of Q2 is 6 times greater than Q1. They intersect with each other. Okay, so let me draw the two demand functions. Let us say this is one demand function, we have another demand function, that is elasticity of demand for Q2 is 6 times greater than that of Q1. Let us say this is demand function for good Q1 and this is demand function for good, or let us suppose it is demand function for good Q2 and this is demand function for good Q1. So these two demand functions intersect at a price of $10. Okay, so what will be the quantity demanded for Q1 and Q2? Because they intersect each other, so Q1 will be equal to Q2, which we need to find out. So let us first find out the Q1. So quantity demanded of good Q1 will be equal to 50 minus the price at that very point, that is 10, so which is equal to 40. So Q1 is equal to 40, which is equal to Q2 here, because they both intersect at that very point. Now we know that elasticity of demand for good Q2 will be equal to the change in the quantity demanded of good 2 divided by the change in the price into P price divided by quantity demanded at that very price of good 2, and it is equal to 6 times. So we have 6 times what is the elasticity of demand for good Q1, that is the derivative of this function, that is the change in the quantity demanded of good 1 due to the change in the price of good 1 into price upon quantity demanded of good 1 here. Okay, so dQ2 upon dP, we are supposed to find out. Price is being given us as 10, so we have 10, quantity demand of good 2 is 40, is equal to 6 times. Now dQ upon dP means the derivative of this function with respect to price, derivative of P is 1, so we write here minus 1 into price is 10 and quantity demanded is 40. Okay, so we have this relationship here. So this 0 0 gets cancelled, 0 0 gets cancelled. We have 2 2s are 4, 2 3s are 6. Okay, okay, I am within the limits. So we have dQ2 upon dP is equal to, so here we have 4 also, into 1 upon 4 is equal to minus 3 upon 2. Okay, solving further. So we have dq2 divided by dp into 1 upon 4 is equal to minus 3 upon 2. Okay, now let us transpose this dp here. So we get 1 upon 4 dq is equal to minus 3 upon 2 dp. Okay, now what will we do? We take the integral on both sides. That means we have 1 upon 4, the integral of dq is q, plus we add the constant of integration will be equal to, here we have minus 3 upon 2, and the integral of dp is p, and we add the constant of integration. Okay, so let us say it is c2. Now we can do one thing here. So we have c2, transpose this here. So we have 1 upon 4 q. So we have q2 here. Okay, let me be specific with the subscript q2. Then transpose it here. It becomes 3 upon 2 p is equal to c2 minus c1. Okay, so which is equal to, we have 1 upon 4. Now we know that q2 is equal to 40. So let us write it here, 40 plus 3 upon 2 times 10 is equal to c2 minus c1. So it becomes here 4 ones are 4, 10s are 40. So we have 40. 2 ones are 2, 5s are 10, 5 3s are 15. So we get here, sorry, here we get only 10. 4 ones are 4, 10s are 40. So here we have 15 is equal to c2 minus c1, or c2 minus c1 is equal to 25. Okay, now we plug this value c2 minus c1 is equal to 25 in this equation. So we have 1 upon 4 q2 plus 3 upon 2 p is equal to, so c2 minus c1 is 25, which implies we have 1 upon 4 q2 is equal to 25 minus, transpose it here, it becomes minus 3 upon 2 p, or q2 will be equal to, transpose this 4, it gets multiplied. So we have 4 into 25, which is equal to 100, minus, so transpose this 4 here. So we have 2 ones are 2, 2s are 4, so 2 3s are 6. So we get 6 times p. So we have this demand function q2 is equal to a minus bp. So in place of a we have 100 minus b is 6 times p. So the correct option should be q2 will be equal to this very function, that is the demand function for q2. I hope I make myself clear in this video. Thank you.